Okay, so here's a situation where we'll be looking at comparing survey results. A survey was done of car buyers in New Zealand and Australia. 312 out of the 800 people surveyed in Australia said the mark of car was important to them in the process of buying a car. In New Zealand, 165 out of 560 said the mark was important to them. Do we have enough evidence from this to say the mark is more important to Australian car buyers than to New Zealand car buyers? Well, let's work our way through this problem. Right, the first thing that we need to do is we need to find the probabilities or the proportion of each. So first of all, do the Australian one, which is 312 out of 800. Now, it's actually really useful to do these ones in decimals because it makes a whole lot of other things easier. So that's 0.39. All right, and then the probability with New Zealand is 165 out of 560. We put that in the calculator, it gets 0.295. It's close enough. Okay. The next thing that we're going to do is we're going to get our rule of thumb estimate for the margin of error. Now, this is not perfect, but it's good enough. All right, so we'll start off with the margin of error for Australia. One over the square root of 800, right, which is 0.0354 will do. The margin of error for New Zealand is 1 divided by the square root of 560, and that equals 0.423. Now we can see from it straight away that it's not going to be an issue. However, we'll continue on with providing the evidence, because that's what we're doing here. The answer's not really as important as the evidence as to why it's the answer. So we want to look at the difference. The difference from the survey, and that's going to be 0.39 minus 0.295. 0.39 minus 0.295 equals 0.095. The margin of error of the difference equals the difference, the first difference, which is we need to do the 1.5 first. 1.5 times, and basically it's this, difference A times difference B. I have to move over here so we can actually see what we're doing. All divided by 2. There should be a plus there. Okay, so in this case here, equals 1.5 times, now difference A was 0.0354. Difference B is 0.04, what is it, 423, all divided by 2. So, putting this in, 354 plus 0.0423 divided by 2 Margin of error of the difference is 0.0583. Alright, that means that the difference between them is 0.095 plus or minus 0.0583. Right, which means that our difference is between 0.037 and 0.153. Right, so given this, the smallest difference we can have is 3.7%. And the biggest difference we can have is 15.3%. Now, in all of those situations between there, right, none of them are negative. There's no negative numbers in there, which means that it's clear that we can be confident that Australians care more about the mark of car than New Zealanders do when purchasing. Now, some things we might want to comment on here if we're looking for an excellence is not just the straight numbers, but also think about how was the survey done, right? Where did the information come from? Was the sample representative? Obviously, the samples are big enough to be able to make a call, so that's not an issue. But being big enough to make a call is not relevant if the surveys are not, or the surveys are not representative. If they don't actually represent the population we care about, then it doesn't really matter what the numbers say. So that's the other thing that we have to think about, and we want to look through and see if there's any issues with that. But basically, that's how we do it. We go through, and the key thing is this right here, that the margin of error for the difference is 1.5 times the difference of A plus the difference of B divided by 2. I hope that was helpful.